got a little silver soldering job here to do. I'm sure it'll be obvious to everybody that's an oil feed pipe for a Marshall traction engine, and I need to put a T-piece into it so I can take another oil feed off it. I've found the unit to fit around the outside of the pipe. I'm going to solder it on, then once it's soldered on I'll drill the hole through into the pipe. Setting it up's been a little bit of a nightmare because I haven't actually, this should have been done on the job sort of thing, not sort of lined up like this, but we'll give it a try and see what happens. It does not take a tremendous amount of heat to destroy the job, but it's actually, the tube's actually brass. So I thought that does melt long before the brass, so it should be alright. You get some heat into it and get some flux into the joint. You can hear the oil boiling about inside the pipe. That's another reason why I didn't want to drill a hole through it. I don't want the oil coming out into the joint, burning, bubbling and boiling. I've got plenty of flux on here, the solder will follow the heat around and we're sure to get a good joint. Getting near there now. Right, that's the solder starting to run in. I'm going to put plenty on because I need to get up underneath here where I can't actually see. It looks good, the punch of course I can see looks good. Right, hopefully I took the right angle in, hopefully it's sealed. There's only one way to find out. Quite a handy tool. Call it third hand, use them for welding, just for holding things. They don't get tired and they don't burn. Right, you can see there the solder has run all the way around, focus you. So there's all the way around there, so hopefully that should be a good joint. The solder joint looks really good. I just need to break down into the pipe now. For that I'm going to use a milling cutter because the drill will be a little bit too fierce as it broke through. It's gentle with a good fit milling cutter. It's certainly having a desired effect down there. Just about there. Right, that's it through. Nice, neat, clean hole, just what I wanted. Next one's just to simply solder this olive onto the end of the pipe. Probably the most important thing is to make sure you've got the union on before you solder the olive on. I'm sure we've all done that before, I know I have. On many an occasion. all the shape. I would flux on the pipe to the cylinder would have pulled up inside that barrel. I thought I would put a little bit more on there. Right, I need to anneal the pipe, that is to soften it to make it easy to bend. All you do is heat it up, cherry red, you either quench it in water or let it cool naturally. And that makes the pipe go nice and soft and flexible. Make sure don't put so much heat on the end where to ensure that start to change colour there now, it's starting to go red. Right, that's it, let that cool down, it'll be nice and soft and pliable. It's very heavy wall pipe as well, so you can bend without clinking, no problem at all. I've got a pulley bracket here off either an Italian or a Chinese vehicle lift. What's happened to it is there's a pulley goes in there with a bush in it, no grease nipple, nothing like that. The bush is worn away, the pulleys went probably sideways, that's the pin that goes through there, and you can see how it's bent. There's just no strength in it at all. That pin's held in with two little circlips, it just pops the circlips off in jams. It's worn the holes in there as well. The lads had 2 new pins and 2 pulleys made, so I'm going to do a machine a groove in the pulley to hold some grease. I'll drill that, put a grease nipple in, put a grease port into the centre, bend these straight, reassemble it, and what I'll do, I'll weld that pin in at both sides. It means once I've welded it in, that's it, it won't be, well, not easily repaired again, but it's just to get things going, because you can't get these parts straight away. Once again, this is not load bearing, it's not safety critical, it's a control cable. Anything goes wrong, the vehicle lift will just stop working. There's no way I'll weld or repair anything to do with safety critical lifting gear which needs to be tested. So first thing we'll do, try and bend this into shape, drill that, put a grease nipple in, just put a little groove in the centre there to hold some grease back together, weld the pin in, and that should be the job good to go again. It'd be nice to put a reinforcing bar across the back, but you can't get in. It's just crap design, that's all you can see. It's relying on that little bit of metal there. So we'll have these bolts on tight enough or whatever, I don't know, but you can see how it's definitely splayed apart. I don't know what these pins are made of because I didn't make them. I wouldn't think it would be anything fantastic, it doesn't need to be. Soft. 5mm drill into that. It's 5mm is a tap and drill for 6. One is going for roughly 20mm, that'll be the centre of it. Right, that's 20mm. Some 6mm threads into the end of there. It's a very brave man that tried to power tap 6mm. I'm certainly not brave enough to try it. Just to make sure the tap's started nice and straight, and we'll do it by hand. This is a tap wrench that I actually made at school, and I've still got it. I still use it all the time. It's one of those things I've kept. There's plenty of threads in there so you can get your 6mm grease knuckle in. We'll put a drill hole through it now so the grease can come out. That's broke through, so the grease goes obviously in there, out through the hole, into the bush, and it'll possibly last a little bit longer. I've got a little grooving tool here. All I want to do is put a groove in the centre of the bush, just to allow the grease to be held. Go a little bit deeper than that. Little groove which is going to hold a reservoir of grease, which is going to do a lot more good than it possibly can harm. Right, next thing is to straighten these or get them somewhere near straight. See how little strength there is in there. Absolutely terrible. Really is. I mean, that there's actually pulled across when it's been welded. It's only been welded on one side and it's pulled across out the straight. Make sure the grease knuckle goes on that side because that's where the access is. So once the pin's welded in, it's welded in, but it's miserable. It is miserable. Anyway, I can't make it better, but that's just what it is. I've got a little bit of packing in there just to hold the pulley central because these holes are worn. Get some tacks on it. I'm using a stainless based rod which is designed to weld the similar metals because I've got no idea what it's made of. And I know for a fact this stuff will weld it without any problems with cracking. The pulley's nicely centralised. Right, that should do the job. Once it gets some grease into there, it's got a fighting chance of lasting a little bit longer. As long as somebody greases it, of course, it won't grease itself. Once again, it's just time to say thanks for watching, thanks for subscribing, and as always, a massive thanks for all the well wishes and all the help and support I'm getting. Anyway, thanks very much.